Have you ever wondered if reality is just an illusion? What if our universe is actually a sophisticated computer simulation? Oxford philosopher Nick Bostrom argues that if advanced civilizations can simulate universes, it's statistically likely we're living in one. Physicist Melvin Vopson is searching for scientific evidence, focusing on gravity as a possible clue, suggesting it might be a cosmic data management system. If true, the universe as we know it could be the output of an unimaginable computation. To truly grasp the profound implications of this idea, let's delve into the concept of entropy. It's a fundamental principle that governs the behavior of systems, both large and small, across the universe. Entropy describes the tendency for systems to naturally progress towards a state of increased disorder and randomness over time. Think of it as the universe's inclination towards messiness. A tidy room left unattended will inevitably become cluttered. Now, information entropy is a similar yet distinct concept. It measures the level of disorder and uncertainty within data itself. The more random and unpredictable the data, the higher its information entropy. Melvin Vopson, a researcher exploring these ideas, proposes that gravity, unlike most other fundamental forces, actually reduces information entropy. It does this by pulling matter together, forming structures like stars and galaxies, and thereby creating order from chaos. This is the opposite of what we'd expect based on our current understanding of the laws of thermodynamics, which generally dictate an increase in entropy. If gravity is indeed compressing information in this way, it could be acting as a cosmic optimization tool, constantly refining the universe's configuration. Just as a computer program compresses data to run more efficiently and use less storage space. This intriguing possibility hints that our universe might be a self-optimizing system, constantly working to improve its own efficiency. This would mean it's actively conserving computational resources, making the most of what it has. Gravity, in this context, could be seen as the universe's built-in data manager, efficiently organizing and structuring the cosmos. A fascinating and perhaps unsettling sign that our reality might be more artificial than we currently perceive. Melvin Vopson's deep background in the intricate world of digital data storage, particularly his work with high-density storage systems, fundamentally led him to perceive information not as an abstract concept floating in the digital ether, but rather as a tangible, physical entity, possessing its own inherent properties. It's a perspective shift, viewing information as something real, not just an abstract idea. This unique viewpoint spurred him to develop the groundbreaking mass energy information equivalence principle, a bold assertion that challenges conventional understanding. In essence, it's suggesting that information, at its most fundamental level, possesses mass, however infinitesimally small. Further expanding on these ideas, Vopson proposed the second law of infodynamics, which boldly claims that information entropy, the measure of disorder within a system, should naturally decrease over time, with the universe inherently favoring order and structure over chaos and randomness. During the unprecedented global challenge of the COVID-19 pandemic, he meticulously analyzed the patterns of viral mutations, tracking their evolution. What he discovered was quite surprising, and found that contrary to prevailing expectations and established biological principles, the virus's information entropy demonstrably decreased as it adapted and spread. This suggested a trend of increasing order and efficiency as it evolved. The virus, in essence, seemed to actively optimize its genetic code, streamlining its functionality. This optimization process resulted in the virus becoming more efficient at replicating and spreading. This compelling real-world example, observed in the behavior of a virus, strongly supports the intriguing idea that information compression, the drive to minimize disorder, is not just a local phenomenon, but a fundamental universal principle governing the cosmos. From the microscopic world of viruses to the vast expanse of galaxies, the universe, in its entirety, may be inherently programmed to optimize itself, constantly seeking greater efficiency and order. Imagine that gravity, the force that shapes galaxies and binds us to Earth, isn't just about attraction. What if, at its core, gravity compresses information, squeezing the very fabric of reality into a more manageable form? This radical idea could potentially explain some of the most profound cosmic mysteries, such as the enigmatic dark energy that's driving the accelerating expansion of the universe. It might even offer a new perspective on the perplexing realm of quantum gravity, bridging the gap between the macroscopic world we observe and the bizarre behavior of subatomic particles. What if the universe's ongoing expansion isn't just a random occurrence, but rather a process akin to a computer upgrading its hardware, adding more processing power and memory to efficiently handle an ever-increasing amount of data? The strange and often counterintuitive nature of quantum weirdness, with its probabilities and uncertainties, could simply reflect the underlying pixelated nature of a highly complex digital simulation, where reality is rendered in discrete units of information. Even the seemingly destructive force of black holes might be reinterpreted as the ultimate data compressors, efficiently storing vast amounts of information, not destroyers of information, but rather guardians of it. While Vopson's groundbreaking work doesn't provide a definitive answer to the question of who the simulators might be or even if they're simulators, it does give us a scientifically sound and testable way to approach the question and to ask it with rigor. Perhaps the most profound and awe-inspiring wonder of all is the realization that our entire reality, with all its complexity and beauty, could potentially be written in code.